In this video, let us discuss electromagnetic waves. That's a small chapter. So generally, electromagnetic, the name itself says that electromagnetic wave is a combination of variable electric field and variable magnetic field. Okay, and remember that the electric field component and the magnetic field component, they are always perpendicular to each other. So the diagram of electromagnetic wave is like this. Okay, here you can see this part is the electric field, suppose this part, and this part is the magnetic field, and you can see that this part and this part are perpendicular to each other everywhere, here also, like this, so they are perpendicular to each other. Alright, this is a very important diagram, you can see it, you can try to draw also. So with this electromagnetic waves, certain things are associated. What are the things associated with this electromagnetic waves? So we know that there is a vector associated with this, we call it pointing vector. In this chapter there is nothing to derive, so certain formulas you have to remember only, like this one, pointing vector. What is pointing vector? It is a vector, and how it is, what is the formula of it? 1 by mu naught. Mu naught means this is called the permeability. You will get to know the what is permeability in magnetism chapter. So for this time being, you just remember mu naught is it's a specific property of air or vacuum. Mu naught, we call it permeability. What is permeability? You will get to know. Okay, so this permeability into cross product of electric field vector and magnetic field vector, cross product. So since it is cross product, we know that their resultant will also be a vector, so that is why this S is called a vector. What is the name of it? It is pointing vector. Okay, then the momentum associated with this electromagnetic wave is U by C. U means it is the energy associated with this, divided by C. C means speed of electromagnetic wave. So speed of electromagnetic wave, there is a formula, lambda into nu. Lambda is the V equals to lambda nu. V means speed of electromagnetic wave, which has a value in vacuum or air 3 into 10 to the power 8 meter per second. Same with the velocity of light. Okay, light is an electromagnetic waves only. Then this one, electromagnetic wave travels in vacuum also, and this is the formula, lambda nu. Lambda means wavelength, nu means frequency. Another thing, intensity of electromagnetic wave is I is equal to half into epsilon naught. Epsilon naught, you know, it is the permittivity of free space. E naught square. E naught means it is the maximum value of electric field component. Means if this is the electric field part, then this part, E naught, maximum value of electric field. Okay, so E naught square into C square. C means speed of light or speed of electromagnetic wave or EM wave. Okay, so these are certain formula that you should remember. Then this electromagnetic wave, this is very important part of this chapter, spectrum, electromagnetic wave spectrum. This electromagnetic wave, it is divided into 7 parts, starting with radio waves, microwaves, infrared, visible, UV, X-ray, gamma ray. So there are 7 part of this electromagnetic spectrum. Here you have to remember that what are the source of this rays, where from we get this. So radio wave we get, okay, about the source we will discuss in next page. Okay, there it is written nicely. So what are the things that you have to remember about these waves, that what are the purpose of this wave, that means where these waves are used, uses of these waves, very important thing, uses. Okay, just a second, I think uses are already written here. Okay, uses are not given here. Anyways, You can see from here only. Okay, uses are not given here, no. Anyways, I'll give you the uses of this electromagnetic waves, but that one you have to learn. Okay, all right. So here, another thing that you have to remember is the range of frequency and wavelength for these waves. Frequency range and wavelength range. This is here only it is given. This one. See, this one is frequency range. This one. And this one is wavelength range in meter. Frequency range in hertz. So first, what was that? It was radio waves. Radio waves frequency range is 10 to the power 9 to 10 to the power 10 hertz. This much, this much. So in this way, you see the frequency or range of frequencies for these rays. Okay. All right. See, this part is visible. Visible means the light that we see. So visible, how much is the range? 10 to the power 14 to 10 to the power 15. UV 10 to the power 15 to 10 to the power 17. X-ray 10 to the power 17 to 10 to the power 20. Gamma 10 to the power 20 to 10 to the power 23. This much of hertz. And wavelength range, you can see this one. Okay, this side. Then okay, about the source, I told you that source is in the next page. So here are the sources. Sources means from where do we get these waves? So radio waves, how do we get? Oscillation of electrons. Just to remember these things. Microwave, where from we get that? Inversion, rotation of molecule. So these things you just remember. You don't have to know much deep concepts about it. You just remember the things. Infrared waves. Okay, so these things you go through. You learn these things. Few more are there. 5 are here and 2 are there. This one. Gamma X-ray and gamma rays. Alright. Now certain things that you should know from this chapter. About this thing already, or not this one, about this one. Pointing vector, already you got this one. So apart from this, you know some other things. This one. Speed of light can be given by this formula. 1 by root over mu naught epsilon naught. What is mu naught? Permeability of free space. Epsilon naught, permittivity of free space. E by B. E means E is electric field part, magnetic field. E by B. Okay. Then another formula, this one. E naught is equal to C into B naught, or C is equal to E naught by B naught. So C means this E by B also E naught by B naught. And E naught means it is the maximum value of electric field component. B naught is the maximum value of magnetic field component. Okay. Energy density of electric field, formula is this one. Energy density of magnetic field, this is the formula. Intensity, I think already you got this one in last page. Okay, so these are the things that you should remember. This one also you got, momentum, in last page. Okay, then certain terms. Okay, certain terms means these things, these are the ranges of frequency. Already I told you about it. If you want, you can learn from this part also. From here also you can see that ranges of frequency. And the important thing about this chapter is uses of electromagnetic waves. Where do we use these waves? The question comes like this. Just an example. Suppose in medical treatment, which of the electromagnetic waves are used or is used? So then you have to write the name of the wave. Okay, you will directly, they don't ask, right, like write the uses of X-ray or write the use of gamma ray. They ask the question in reverse way, means for this purpose which ray is used. So that means you have to know all the purposes, all the uses, almost all the uses. Okay, okay, I'll give you the uses. So this is all about this chapter only. Then in the next video we'll discuss about wave optics. Okay, thank you. Thank you.